Okay. The Fourier analysis has the two parts, as I mentioned. And the first part of Fourier analysis is said to be the Fourier series. Okay. And the second part is called as the Fourier transform. Fourier series and Fourier transform. Now, if we understand the basics behind when to apply Fourier series and when to apply Fourier transform, this becomes very easy for us to continue. Okay, so the Fourier series is applicable for any signal or any function which is periodic. Okay, and the Fourier transform is applicable for any function or any signal which is non-periodic. Okay, one is periodic, one more is non-periodic. This is very basic difference. Anyway, we'll come back to this when we discuss in detail. Okay, now let us look at one concept today in the demo session. And the topic which I'm going to cover is what is a transform, or what is the requirement of analyzing the signal uh, function by taking the transform. Okay, so let's look at what is this. This is the important concept before learning any of the transform. Okay, now let us say we have the signal in time domain. For example, let us consider a signal time versus amplitude. Maybe this is a signal, this is a function. Okay, ಅಂದ್ರೆ ಈಗ ಒಂದು ಸಿಗ್ನಲ್ ಇದೆ ನಮ್ಮ ಹತ್ರ, ಟೈಮ್ ಡೊಮೇನ್ ಸಿಗ್ನಲ್ ಅಂತ ಕರಿತೀವಿ. ಇನ್ ದ ಸೆನ್ಸ್ ಯು ಆರ್ ಪ್ಲಾಟಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್. ಓಕೆ, ಸೊ ಪ್ಲಾಟಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್ ಇನ್ ದ ಸೆನ್ಸ್ ಮೇ ಬಿ ಇಟ್ ಈಸ್ ಎ ಟೆಂಪರೇಚರ್ ಡೇಟಾ. ನಾವೇನೋ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿರ್ತೀವಿ, ಮತ್ತೆ ಆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನ ರಿಸಲ್ಟ್ ಆಗಿ ವಿ ಹ್ಯಾವ್ ಕಲೆಕ್ಟೆಡ್ ದ ಟೆಂಪರೇಚರ್ ಡೇಟಾ ಫಾರ್ ಎ ಗಿವನ್ ಡೇ. ರೈಟ್, ಯು ಸಿ ಇಟ್ ಈಸ್ ಟೈಮ್ ವರ್ಸಸ್ ಆಂಪ್ಲಿಟ್ಯೂಡ್. ಯಾವ ಹೊತ್ತಿಗೆ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಇತ್ತು ಅಂತ ನಾವು ಪ್ಲಾಟ್ ಮಾಡಿದ್ದೀವಿ ಅನ್ಕೋಣ. ದಿಸ್ ಇಸ್ ದ ಸಿಗ್ನಲ್, ದಿಸ್ ಇಸ್ ಎ ಫಂಕ್ಷನ್. We can write an equation for that, so that's why it is called as a function. Okay, in this now let us assume that my intention is to identify various parameters of such function, the horizontal axis, right? Andre kelagade x axis alli navu ಏನು ಬರಿತೀವಲ್ಲ, so that is a variable. Y axis is another variable. Okay, so in case of in such representation, whatever you write in the horizontal axis is called as the independent variable. This is independent variable, right? Why it is independent variable? Because along the x-axis you can take all the values from minus infinity to plus infinity, no restriction. Which means at time t is equal to, say, minus infinity, we have some value for y. At t is equal to plus infinity, you have some other value for y. Okay, so that is what is the meaning of when I say we are trying to write the function and it is said to be independent variable. Now whatever you write along y axis, right, andre illi amplitude anna plot ಮಾಡ್ತಾ ಇದೀನಿ, that particular variable is said to be the dependent variable. Okay, so I'll write dependent variable. Okay, now let us assume that we collected this data and we have saved this data in some location, maybe, right, in a computer we have saved it. Idanna ನಾವು ಕಂಪ್ಯೂಟರ್ ಗೆ ಹಾಕಿ ತೆಗೆದಿಟ್ಟಿದ್ದೀವಿ ಅನ್ಕೋ. Now I want to see the same plot in a different view. ನನಗೆ ಅದರ ವ್ಯೂ ಚೇಂಜ್ ಮಾಡಬೇಕು. What I want to plot is something like this. Vertical axis is still amplitude. Okay, but the horizontal axis, I want to measure the frequency, right? You see, assume that this is a temperature data. Temperature data means for a given specific temperature, right? Let's assume this is a specific temperature like say 25 degrees. In a day, 25 degrees may reach 3 times. So what I want every temperature, how many times it is repeated, right? You see, it's the same values, but being plotted in a different way, right? ಯಾವ ಟೆಂಪರೇಚರು ಆ ದಿನದಲ್ಲಿ ಎಷ್ಟು ಸಲ ರಿಪೀಟ್ ಆಗಿದೆ ಅಂತ ನನಗೆ ಬೇಕು. Okay, so I'm measuring that quantity. So this is no more time. So you see the previous plot was time. X axis ಅಲ್ಲಿ time plot ಮಾಡ್ತಾ ಇದ್ದೆ. ಈಗ x axis ಅಲ್ಲಿ ನಾನು frequency plot ಮಾಡ್ತೀನಿ. Right? So frequency versus the amplitude. ಈಗ ಇದನ್ನ plot ಮಾಡಿದ್ರೆ ನನಗೆ ಅಲ್ಲಿರೋ ತರಾನೇ ಗ್ರಾಫ್ ಬರಬೇಕು ಅಂತ ಏನಿಲ್ಲ. You may get a graph like this. You see, it is completely changed. Because of change in the x axis variable, my graph looks different. Right? I am looking at the frequency, number of occurrences. All right. So when I look at the number of occurrence of a given particular quantity, right, I change the x-axis of my plot. So whenever you are trying to change the x-axis of the plot, this is right, the transform, the change you are going to make over there is what is referred to as the transform. Right? So you are transforming time domain into the frequency domain. Illu kuda namadra x-axis is the x-axis and y-axis variables we have. X-axis is called as independent, y-axis is called as dependent. Even here, right? Yavade graph kotru idanne follow ಮಾಡ್ತೀವಿ. Okay, so see here, this means the amplitude versus frequency is plotted, but the view is different, right? When I change the time axis into the frequency axis, ಇಲ್ಲಿ ಬೇರೆಲ್ಲ parameters same ಇರುತ್ತೆ. Only thing that is being changed here is the x-axis time into frequency, right? So ಹಾಗಾಗಿ ಇಲ್ಲಿ ನಾವು x-axis ಅಲ್ಲಿ ಏನು ವೇರಿಯಬಲ್ ಅನ್ನ ಪ್ಲಾಟ್ ಮಾಡ್ತೀವೋ that is called as the domain of the particular function. So you see what we actually ultimately did. I'll write here. I had a signal which was plotted in the time domain. Correct? Because the first function, right, first plot is in the time domain. I took a transform, right, and I converted this into the frequency domain. Right? The one tool, right, which performs this kind of operation is what is called as the Fourier transform. So ಈಗ basically Fourier ಅಂತ ಹೇಳೋ ಟಾಪಿಕ್ ಇದೆ ನಮ್ಮ ಹತ್ರ. What Fourier performs is just this transform. Right? Time domain ಅಲ್ಲಿ ಇರುತ್ತೆ ಸಿಗ್ನಲ್, ಅದನ್ನ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ತಗೊಂಡು ಹೋಗ್ತೀವಿ, right? That kind of transform is what is called as Fourier transform. Actually there are many other transforms available, right? Depending upon your requirement, you can use any transform that you want, right? We have equations coming up at a later stage, but for the time being, I have not considered any of the equations.